Hey, how y'all doing? Okay, so today we're going to be going over rotations and the notes. Okay, so a rotation is another type of transformation. So we've done translations, reflections, we have rotations right now, and the last one we're going to be learning about are dilations. Okay, so rotations. A rotation blanks a figure around a fixed point called the center of blank. Okay, so a rotation, right, is whenever you're doing this, right? Basically, I just did a spin. Right? So a rotation spins a figure around a fixed point called the center of rotation. Okay? And for our example, the center of rotation will be the origin. Okay, the origin is the very middle of the graph, or 0, 0. So it's the origin, okay, otherwise known as 0, 0. Okay? And we will rotate in increments of 90 degrees. Okay. So when it says pay attention to the direction of the rotation, we can move in two directions in rotations. We're going to move either clockwise or counterclockwise. Okay. So this one right here is going to be clockwise, and over here is counterclockwise. And this one right here is really important. Okay, so consider each quadrant as another 90 degrees in rotation. Okay, and I'm going to show you what that means in a little bit. Okay, right here, really important. Consider each quadrant as another 90 degrees in the rotation. All right, so let's scroll down over here. Let's look at question 1. Find the number of degrees in each rotation shown below. Okay, well, I start out with A, and I know I'm starting out with this pentagon A instead of this one because this one has the prime mark. Okay, so I'm starting out right here, and let's see, it's asking for clockwise first, so I'm going to go rotate once clockwise over here. Okay, and if I go back, it says that consider each quadrant as another 90 degrees in rotation, and we'll rotate in increments of 90 degrees. We rotated once, so that means we rotated 90 degrees clockwise. Okay, so that's 90 degrees. So now we're going to go counterclockwise. Well, counter would be the other way. So we're going to go here first. That's 90 degrees. All right, and we go here. That's another 90, so plus another 90. And then finally we're going to end right here. Okay, plus another 90. So 90 degrees to go down here. Another 90, so 90 plus 90 would equal 180, okay? And then another 90 degrees to get where it is right there. 180 degrees plus 90 is 270. So 270 degrees. Okay, let's look at this one. So again, we start out at this triangle B down here and not this one because that one has the prime mark, okay? So if I go clockwise, I need to go like this. Okay. So whenever I go right here, that's 90 degrees. Okay. And I'm going to add another 90 when I go into this quadrant, quadrant 3, and then another 90 to get to quadrant 2. Quadrant 1. Okay. So 90 plus 90 plus 90 is going to get you 270 degrees. So we rotated 270 degrees clockwise to get to where it is right there. And then the other way would be counterclockwise, right here. And that we only rotated once, and we know that each rotation is 90 degrees. Okay. All right, so let's start right here. We're going to go clockwise. That's 190 degrees, so 90 degrees. And then another to get where it is right there, 90 degrees. 90 plus 90 would equal 180. So that was clockwise. Now let's go the other way. Let's go counterclockwise. We're going to go once right here. So that's 90. And then another 90 degrees. And would you look at that? 180 degrees again. Okay. So I'm going to scroll down. I'm going to show you all this. I'm going to let y'all pause it. Okay, try these next three on your own. All right, so let's throw down. Rotate the figure shown at the right 90 degrees, then 180 degrees, and then 270 degrees clockwise. After each rotation, record the coordinates of the image in the appropriate table. Okay, so there's two ways that we can do this, all right? Well, one way is if you know the algebraic representation off the back of your head, which if you're new to rotations, I don't expect you to know it. So what I like to do is, well, it's telling me rotate it 90 degrees clockwise. Okay, so that means I'm going to take this whole thing and rotate it once 90 degrees to the right, like that. So now I can see that this is my new y-axis, and this is my new x-axis. So where is this new point A going to be at? Well, A is going to be at 1 and -2, because remember, when you go down from the origin on the y-axis, you're going negative. So 1 and -2 for A prime. So let's get back up here. A prime, when we rotated 90 degrees clockwise, we said is 1, -2. Okay. Let's see. B prime would be 1 and -6. All right. 1, -6. And then C prime would be 7 and -4. Okay. 7 and -4. Okay. So let's see. What would the algebraic representation be? Well, I know that an algebraic representation will always start out as x and y in the parentheses. Okay. And then this arrow drawn after it shows that a transformation is happening. That means that something is changing. Okay. So it goes from just a regular x and y right here. X value and y value, okay? Well, let's see. We have 2, 1 as our first ordered pair, and then A prime right here, B prime and C prime, okay? Well, what changed? So the 1 was originally in the y value spot, but then after the transformation, it changed into the x value spot. So we're going to write y right there, and then let's take a look. Our x was originally a positive, and then it switched into a negative, okay? So that means we're going to draw a negative sign in front of the x, okay? And remember, just as you see an algebraic representation that has a negative sign in it, that doesn't mean that the number is always going to be negative. It's just going to be opposite of what it originally was. So if it was a negative, it would be positive. If it was a positive, it would be a negative, okay? So that's the algebraic representation for a 90 degrees clockwise turn or a 270 degrees counterclockwise. Okay? In our words, how can we explain this? Well, the x and y values switched spots, okay, and the x value sign was flipped. Okay. And what I mean by that is that this x value was originally a positive 2, and then it became a negative 2. Okay, so let's look at 180 degrees clockwise. So if one rotation is 90 degrees, if I add another 90, that's how we get to 180. So let's take a look. Now we have, this is my y-axis, and this is my x-axis. So let's go ahead and look. A is now at -2, -1. Okay. So now my A prime is going to be at -2, -1. All right. So let's go back. B prime would be at -6 and -1. Okay. So now this is going to be at -6, -1. And then C would be at, let's see, C prime is at -4, -7. Okay. -4, -7. Alright. So what's the algebraic representation for this? Again, we always start out as x and y, and then we draw that arrow, okay? That tells me that something's transforming and a transformation is happening. Okay, so let's see. We had a positive 2 and a positive 1. Well, the x value, when the transformation happens, okay, that x value stays in the x value spot, but it changed signs, right? It changed from a positive to a negative. Same thing for the y. So we can write our algebraic representation as negative x, negative y. Okay, that means that whatever the signs were originally, we're going to flip them. Okay, so how do we explain this in our own words? Well, the x and y value signs were flipped. Okay. All right, so let's go back. Okay, so now we're looking for 270 degrees clockwise. So that means if 180 is 2 rotations, 270 would be another one, which would be 3. 1, 2, and 3. Okay, so now let's look. Well, look, our x and y axes are now flipped. We have a new y-axis right here and an x one right here. So now this A looks like it's negative 1 and positive 2. Okay? So we got negative 1, positive 2. So I want you all to go ahead and try by yourselves to fill out the rest of this. Okay? Pause the video, and then I'm going to write the answers. Okay? So B prime would be negative 1, positive 6. C would be negative 7, positive 4. So what happened here? Okay, well, we have x and y start out. Okay, that transformation happens. And then, well, our y went to the x spot, but also it changed signs, right? This changed from a positive 1 to a negative 1, positive 1 to a negative 1, and positive 7 to a negative 7. Okay? So this is now going to change, and we're going to put that negative sign in front. Okay? And x. So, in our own words, how can we describe what happened? Well, the x and y switched spots, and the the y value sign was flipped. Okay. So the coordinates below represent rotations. Use what you've learned today to describe what type of rotation occurred. Go ahead and pause the video and try for yourself, and I'm going to go ahead and write these answers. So this would be a, let's see, we flipped, and our x became a negative, so the x value changed. That's a 90-degree clockwise, otherwise CW rotation, / 270-degree CCW counterclockwise. Well, over here, again, they flipped, okay? They flipped, and this negative 4 stayed at negative 4, so the x value didn't change, but the y value did, right? It changed from a positive 5 to a negative 5. So that means to say 270-degree clockwise rotation, or CW, / 90-degree CCW counterclockwise. Okay? And this one, they didn't switch spots, but they did flip signs, so that means it's a 180-degree rotation. Okay? And 180 degrees clockwise, the same as counterclockwise as well. Okay, so question 11, do rotations preserve or change the orientation of the figure? No. Okay, and I don't have to worry about question 12. All right.